All right, I'm just going to do a short little introduction. Today's topic, we're going to show you how to build an Oracle with Phat Contracts, and then kind of dive into an extension of this implementation where we utilize an off-chain rollup palette to ensure that these Phat Contracts can execute an atomic transaction on a substrate-based chain. So for me, my name is Joshua. I'm a dev advocate, but I also am a dapps developer at Phala Network. These are some of my usernames, so you can contact me in my email. And so what are we going to cover today? So what you're going to learn is about how to build get closer to building a decentralized Oracle that's fully customizable. The one that we built over the last just 2 weeks, it just fetches a token price through these HTTP requests to CoinGecko, so you can see that on the right side of your screen. We interact with their API to get the token pairs, and we then take that information and send a HTTPS request to an RPC node on a substrate chain. In this case, we use our Phala testnet. And that feeds the token price to the substrate chain. This all also is running in our Phat contracts, and our Phat contracts are running in our secure enclave off-chain workers. So this is where we get that ability to make these calls to the internet, essentially. And then we're also, the Phat contracts are also written in Neat, so you can get some experience writing some contracts, in our case, Phat contracts, in Ink and these based WASM smart contracts. So whenever you finish the challenge today, there's going to be a beginner remark NFT that gets airdropped to your account after you complete the beginner challenge. And then over the next couple of days, we're going to finish off the advanced remark NFT challenge, where you'll be able to implement this on your own, and then we'll have also a Phat contract that will airdrop the remark NFT to your Kusama account based on your completion of the challenge. So why build a new Oracle? Well, today there's a lot of limitations with integrating an Oracle into your blockchains. For instance, the standard is Chainlink. And they only support, I think, well, here it says 12 EVM chains. Someone can check me on the multiple chains that they do support, but they're EVM-based chains. So there's very limited support. And then if you are added to the list, it's going to take a while for you to get your implementation done and have some developers actually want to build on top of your platform. Also, there's just not much flexibility. Typically, these oracles are going to be more of just a price feed for your exchanges, or implementing some type of VRF, and they're really incapable of processing any kind of complex data. And then also on the last part is if you want to build a custom Oracle, it's gonna be very hard. It's gonna take you months, maybe a year, who knows. And there's just not really, like in the middle point, not much flexibility for you to really tailor your Oracle to your needs. So the keys to building a flexible Oracle would be being able to have internet access, so making these HTTPS requests to connect to Web3 services, but not only that, also Web2 services, because you want to give your developers options opposed to a constraint of saying it's decentralized or nothing, but maybe somebody doesn't need a decentralized storage to connect to through an HTTPS request. Maybe they want to use a Web2 centralized solution, but that's a part of this flexible Oracle idea here. We also want it to be programmable, so you want to be able to customize this arbitrary logic for your oracles, such that it can fit your needs, and then also have easy integrations. So you want to be able to say, I want to build on the best technologies, and I don't want it to take years for them to actually integrate together. Say like it's a cutting edge technology. It's really hard to innovate whenever you're blocked by a solution that cannot really fit your needs, or you have to force yourself into a corner to where you're having to use a specific stack, and it's really hard to escape that limitation. So this is kind of where the fat contracts come into the play. So the fat contracts are the secure enclave off-chain workers, and they're going to have access to the internet. So you're going to be able to make these HTTPS requests. You're going to interact with Web 2 or Web 3 services. They're programmable. You have the ability to have a programmable oracle with the fat contracts that support the Inc. Embedded DSL, and also it can work with any chain. So we have it to where we've enabled a request and response to like Substrate and EVM based chains, and it's not even that much code. It's I think like without the comments like explaining like what's going on through the process, it's very minimal, less than maybe like 150 lines, if that. So just to kind of go over what we built, and just to like harp on the time to build a proof of concept. It took us 2 weeks to do this, and this is a price feed oracle for Substrate. Like we've already built a EVM based like this type of like off-chain rollup in the EVM based chains, but we wanted to show that here at Sub0 that we can also build something on Substrate for Substrate chains. So this is like so with this palette, you're able to watch requests, or like with the fat contract, you're able to watch requests by interacting with the Substrate palette. So this is gonna allow you to then create some kind of how do I explain this like properly? But it's gonna allow you to interact with one, a Substrate-based blockchain, and then two, the Web 2 service where you're trying to get these token prices. So in this case, we use like CoinGecko, and then also respond to that price data. So like with the scheduler, you're able to schedule like a period of updating your price data by triggering a call from your fat contract to interact with that API to get that token price data. And then to make this reliable and ensure that the information that is being sent to Substrate is atomic, we created this off-chain rollup palette. So for like, if you have like a very, very deep technical question and you want to talk to our core developers, you can go to our Discord and talk in the dev channel, and we have people on standby to answer your questions, especially if you want to know like some deep core understandings of the architecture that we have built. So this is a QR code for you, or if you want to use the link discord.gg/Phala. And then here's a QR code for the repo. So here's a short link, and in this repo, there's a README, and it's a very descriptive README written by our co-founder and lead dev Hongyan. So definitely, if you want to read that through now, you can check out the link here. It's like bit.ly/fat-sub0, or scan the QR code. And then we also have a fat contracts UI. So if you want to start building some proof of concept fat contracts, I'll show you this a little bit later. But it's fat.phala.network, and there you can load your compiled fat contract into this UI and then interact with it, whether it's queries or transactions. But mostly we utilize queries because the queries are not going to have any latency and they're going to execute right away. And that's actually how we make these HTTPS requests as well. So there's no cost in making these HTTPS requests. So the beginner challenge. Yep. Here.
Can you hear me better? Yeah. So just for me to get what you're saying. So let's assume you have a Yahoo price source, yeah? Yahoo Finance price source. So we would be able to use an API that you built to essentially access that price source and create like a off-the-shelf Oracle into our smart contracts.
Yes, yeah. So you'll be able to customize that fully on your own, and you get to pick whichever like APIs you would like to communicate with. Again. All right. So now we're gonna step into the beginner challenge. So to do this beginner challenge, whenever I'll walk through the steps, but just to kind of give you like a high level overview of what it will look like. So this is whenever you'll be in the Phat Contracts UI, you'll click this button called Attach, and then there's a contract ID here that you'll copy, add that into the contract ID form, and then also you'll want to download the code from our repo so that you can get the compiled binary so that you can load the .contract file into the Phat contract so that you can then come to this like UI here where it's like a Sub0 factory for you to like in this case like generate a token pair that you want to submit to the price feed. And just like a warning, don't do like Bitcoin and Dogecoin because yeah, this is like it was just like a real quick implementation, but yeah, it won't. It'll error out if you do something that's too much of like too big of a number essentially. But you could end up implementing something that would be able to handle that. That's just the flexibility that we enable you to have with the Phat contracts. So let's see. I think. Oh, and then I'll also like after this slide, I'll show you like the steps of doing it. But we also have our parachain, like the Phala development testnet with that Phat Oracle and the Phat rollup. Like it's like a Phat rollup anchor palettes. And this is where you'll see the once we create a token pair price feed, it'll display here, and then the scheduler will fetch that price feed and then publish it on the Phat Oracle palette. And then later after this presentation, you'll get airdropped a Remark NFT. This says code, but let's step through the process really. So in this case, I've already loaded a couple in here, but what you'll do is you'll click this attach button, and this is where I loaded the Sub0 factory Phat contract that we created. So for right now, I'm just going to go in. You should expect something like this, right? So Sub0 factory, your contract ID, you'll have like a config, which is like only accessed by the contract owner, so you can like implement that access control for your like queries and your transactions. Then you have like a git config, which is going to return your current public config. And a nice thing about this like this UI is you have some like events, some results, and some logs. So if you query this, let's see if my internet connection is good enough. Let's see. I think. So here you can see we have our like encoded data here for the git config and some information here to show you the message output from the logs. So we're able to do a log server on the testnet because we have this like this side VM implementation, but that's like down the road. It enables us to do some logging on the Phat contracts in a test development environment for now. So just to see some of the past deployments that we've done just over the last day, these are going to be your Git deployments. So after you do this transaction, I just wanted to show you what you should expect to see. So, for instance, like our lead dev and co-founder Hong, he created 2 token pairs here, and whenever you deploy this price feed, it's going to actually deploy a Phat contract that's interacting with API to get that information for that 2 token pairs that you submit. So you'll see that the owner will be your account here, and then you'll have your contract ID that'll show how to attach and then upload whenever you submit your deploy price feed. So these are 2 of his, and then we have like a few of mine. Maybe stable pair. The maybe stable pair is like USDT and USD, and then a hash pair. But let's just kind of try to do an example. And for this like workshop, you'll be able to do this by going to like CoinGecko's API. And the two important ones that you would like to have is one from the coin list. So here's all the coin lists here, and you'll want to use like, let's say let's just put like Bitcoin or something like. So you'll use this ID as your first parameter after you name your price feed, and then the next parameter you will use is called the supported versus currencies, and that will give you a response here. Like these are all the supported ones. So you have like USDT or USD in here. I wonder if they have. No, but they have like BTC, all sorts of ones in here that you can set as a second parameter. So these are just go into this CoinGecko API. That's how you can complete the first beginner challenge. So I'll create a name like Sub0 WS for a workshop. I'll pick Bitcoin, and I'll put USD. Just to preface this, I want to see what the price is, see how much it'll differentiate in this short time, but okay, cool. And also, when I show that slide of like the blockchain, we can look at this the recent blocks that have been added. You can see as we add this new price feed, and it get deployed as a contract. So we start here. I'm going to hit run. So you pay for the deployment of the contract, and that's it. After that, all the requests that are processed will be handled by the scheduler, and there's no cost there. So we can look at our logs. See, we're at 22.4. Where are we at? 2.4. So based on the events, transaction payment, balances, deposit. Okay. Let's see if we got anything else. So let's take a look at the Explorer. So it looks like, okay, so this is good. So just to like explain what just happened. So we deployed a Phat contract. It was instantiated into a cluster of computation workers. And once that was instantiated, there was the scheduler triggered the Phat Oracle to go get a quote and receive it. So we got like 16, whichever. I don't like it might differentiate slightly. Let's see if we can like look at it again if it's closer. But you'll see here down here like this is the price that was fetched at the time of the quote received, and then this is the part where we have the Phat rollup anchor rollup executed so that this contract's actually communicating with the Phala blockchain. It's it has like a quote that needs to be fulfilled. It receives that quote, and then the rollup is executed so that it stores on chain. So now when we go over here to this chain state and we take a look at the Fat Oracle, then we can look at the price feeds. And for this instance, we'll look at the one that I just deployed with the Fat Pusher. I have multiple in here, so we can kind of look at which one's deployed. So we have one that I did earlier with Polkadot and Chainlink here, and then we have one with Kusama and USD, and then this is the one that we just did with Bitcoin and USD, and this is the price that it fetched here. And here's the timestamp of when it was fetched as well. So these are like just like a basic example, but you can like go even further with like whatever like type of off-chain computation you really need. It doesn't even have to be Oracle. You could just implement a VRF, or you could kind of build out a customized solution. And then also with the Fat contracts, we also have a library where you can connect to like a key value like DB, like whether it's like a decentralized service like Arweave, IPFS, or you could use like AWS S3. That's we have like a library in our Phala to enable you to do that. And then we have some libraries coming with like Sub0, which will allow you to interact with substrate-based chains. And then we have a Pink Web3, which is allowing you to interact with EVM-based chains from the Fat contracts. And then we also have a design that's in this repo that you'll be working with the EVM-based like rollup banker. So let's go back and check deployments just to show some more results. Oh, I already did. Okay. Yeah, there it was. Oop. Sub0 workshop. Another thing though, just to like kind of show you like the next step, you also want to do this attach, just to show you like the process. You would hit attach, and then we had this contract ID here for our demo. Paste that here, and this is where you'll take the .contract file. So you'll add that twice, and then hit submit, and then this pulls up our price feed. Here we can query the owner of this contract, and you can see it's the Fat Pusher account, and I had like 10 Phala tokens deducted from my account. Let's see, and I'll just like show you my, well, it's like a converted, I think it's this one, yeah, you can see that here, like that's the translated version for our testnet. Move it back because things get buggy on testnets. Here, and then this right here. So whenever I was talking about that scheduler, the scheduler is calling this maybe a init rollup for the first time. So then, like, if you were to beat the scheduler to this and hit it yourself, it would give you like the encoded data format of OK, but whenever it's already been enacted, you'll get just a null value. Just to kind of show you that, and then the scheduler for an interval, I think we set it to like every 30 seconds. It'll call this like feed price, and then it'll go fetch that price. So for an example, I'll do it manually, and you can see like this information here, and we can go into the price feeds again, see if we can find it. Not. So, I think that's the right thing, but oh no, it's not. It's because that's not the data is like, okay, sorry. So there's like it's encoded data. So whenever you break it down, you'll have you'll have the account ID, and then you'll have the token pair, and then within that as well, you'll have this this contract ID, the price and time step in milliseconds. So that's what that hash was representing. So whenever it's decoded, you'll get this value here. So in our case, it would have been this value right here. So let's go back to the slides. So just kind of give like a high level like code breakdown. I can even like after I go through these slides like pull up my code and kind of show you some other tooling and like what it looks like. So with the fat contracts that are written in Ink, you have your storage just like how you would develop your contracts in Ink. Like for instance, like there's multiple platforms that have this, like the Sheehan network will allow you to develop these like WASM Ink smart contracts and other tooling services and some really good like documentation that's like similar to like Open Zeppelin is like OpenBrush. They have like some really cool stuff. And yeah, so like in the storage like format here, like for our sub factory fat contract, you're gonna have that owner. So like whenever I was showing this earlier, had the owner, the config, and the deployments. This is like a vec of all the fat contracts that are deployed for these like sub price feeds. So whenever you submit that the deploy price feed, this is the deployment. So it'll have your like your contract ID in these deployments, and then the number that's deployed in the Sub0 factory fat contract. Just to kind of like look even further, so this like config here. So this config is the palette. So in this case, like the fat roll-up anchor and the fat oracle. So these configs. So in this case, we have like an RPC endpoint that we're targeting. We have the palette ID of that palette, the submit key, which will be the account that will be executing the transactions to the blockchain, I believe, and then like a price feed code, so that encoded code hash of the price feed information. You also have this struct down. Whoops, sorry. You have this like structure also down here for like your deployments, but this is like not relevant in this like first step for the storage of the contract state. You also have like the immutable calls. So in this case, like the deploy price feed. So you did have to sign it because you're executing that transaction to deploy your fat contract through the factory palette, the Sub0 factory palette, or I mean fat contract. Sorry, mixing them up. But yeah, so this is like an example of a mutable call. You'll see this like ampersand mute self here for the deploy price, and if you've developed in these WASM Ink smart contracts, you'll like recognize all of these like this syntax here, and then you can see as you lower, like you have like a deployed for this like sub price feed default. It's also down here. It'll go down for this next page. It's kind of continuing the code, but it will then like push this deployment on and encode it, and then return that deployed account ID. So whenever we get that returned account ID, that's a representation of the deployed contract, so that we can then use that and attach it in the fat UI and then interact with it. But the fat scheduler is able to like invoke that contract so that we can have this like interval for these price feeds to be updated at whatever you choose. Right? In our case, we just did 30 seconds for this like this testnet. We also, and then just like kind of going into some queries and like immutable calls. Here's like us like retrieving like the deployments. But in the next slides that I'll show, I'll also show you that like we use like HTTPS requests in query strictly because that's going to execute immediately, and it allows us to kind of get around this like limitation of waiting on the consensus of the blockchain to get information, and then also not having to pay that fee on our network just to retrieve information from like HTTP endpoint. So this is like the powerful thing that we have with these immutable calls for the HTTPS request. And then since we're also these secure enclave off-chain workers, since they're all that code is executing within the secure enclave, you don't have to worry about this enclave being tampered with. They can't tamper with the enclave. They may, like, in the like very small chance that they can even like execute a side channel attack on one of the clusters of a specific miner and be able to decrypt the end-to-end encryption communication, then in that case, they still, the execution of that Phat contract will still go all the way through. It'll just be like, you won't have, you'll have just like the contract states of that cluster like decrypted. But in that case, you would want to invoke a governance call to be able to then do a key rotation and pass a new key for that cluster. So just to kind of like show you like the syntax for these HTTP requests, for this case, this is the CoinGecko API that we use. So you'll see that we like formatted to be able to get this like token 0 and token 1 that you configure in your deploy price feed query in the Sub0 factory palette. Or I guess in that case it was the transaction. My apologies. And then here we have this pink extension called HTTP GET and HTTP POST. So that is like extended from our pink implementation, which is like Phala Inc. And this is how you're able to make HTTP requests. So this next part is like parsing the data. So this is a good example of using like a modification, because like in general, like Inc. smart contracts don't support floating points, because then you know, you won't have like a deterministic execution. So here's like a example where we kind of like modified like a combination of like Serde and like the Serde JSON core, which is like I think we call it pink Serde or something like that. I don't know if it's in here. Yeah. Oh, or pink JSON, that is. And this allows us to use some fixed points and be able to like retrieve that price feed. So you can look at this example and even look at the code just to use it based on whatever use case you have, like you want to develop on. And also just like that access control. So now, like just like with your Inc-based smart contracts, you can put some access control in place, or maybe you want to implement your own role-based. I think there's like something done with by Perry that's a role-based access for the contracts, but I'm not fully sure. But I think they have something there that you can leverage since we support Inc. But this is kind of like how we're able to for those price feed contracts that get deployed by you. This allows us to ensure that anybody that isn't your account doesn't get that information. So it's like kind of like only you can interact with that sub-price feed contract. And then I'll just do high level. I won't dive into it deep. And if you do have some very technical questions about this off-chain rollup implementation, our co-founder Hong Yin, he'll be able to like step you through it and give you like a full detailed explanation of what he implemented. But from a high level, this off-chain rollup allows like these Phat contracts to like use the blockchain as a database, like with like asset guarantees. So the following features, like to kind of like give you the high level, is we allow for like the read for the client. So you'll have like a session to read it, write it, apply the actions, and then whenever the action is ready to be executed, then you commit and submit the transaction to the RPC node. So then you can know that your transaction that you sent from your Phat contract actually gets executed. So on top of that, this is like kind of like the whole thing that I had mentioned at the very beginning about the request and response pattern. So in this case, like it's pretty much using the palette as like a queue for you to just push, read, and answer. I think that's the last slide. Or oh wait, yeah, this is like a example of like how you could integrate it into your substrate palette. So like say you want to get adventurous and work with like I don't know, like work with the Swanky node and then add a palette, like a roll-up palette on the Swanky node, and then maybe we have some tooling, like we're doing some integrations with the Swanky team as well, like at A-Star, and maybe you want to test this out and try to build something customizable. Well, you could add this example palette to your Swanky node, and then try to implement this trait on response, so that this on response gets triggered as a callback in your palette implementation. And then you can also add multiple traits to have this like on response like trait. So here's like this. Thank you. And does anybody have some like questions right now? Yes. I think it's like for the consumer chips. So like they still make them for the Xeon, like the enterprise servers. So that's kind of like the angle that they're going now. So they're not. Okay, so the question's talking about are we gonna stick with TEs as a architectural design of how we build out our Phala blockchain architecture? And the answer is, for us, like we have this like modular architecture so that we can support multiple like different TEs. So like one of them would be like AMD SEV, ARM Trust Zone that we've done some research, and then our lead researcher has like implicated that we do have the ability to like look further into maybe like a secure multi-party computation like type of implementation. But yeah, just like down the road, we do have that in like kind of like the back of our mind. But right now, it's like this solution that we have with is like these off-chain workers that are in different clusters. You have this gatekeeper that's doing a key rotation to deploy keys to each cluster, and then they are able to then use these cluster keys to derive keys for the contracts, and then encrypt their state and then pass it back to the gatekeepers. This is like this is in a pretty secure design, and in this case, you're also not having to adhere to the latency of all these privacy preserving types of technologies, at least like from like what I've seen in this space when it comes to like off-chain computation models in general. But yeah, it's definitely something that we do think about, though. Yes. So, because like
the holder of the key. You have employees who act on behalf. They can obviously change. Yeah, you can fire someone, hire someone. So how is Phala thinking about that? I mean, you're obviously on the right track in terms of privacy preservation on a blockchain, but I have not yet understood how you deal with with this context of business entities, or essentially higher hierarchy levels than the actual user who needs to use or interact with the blockchain.
Okay. So how do they secure their keys from being leaked, or how do they ensure that they have access control for their employees whenever they act?
Exactly.
Okay. Yeah. I mean, that's where you can do some role-based access control implementation, so that you're able to say that, oh, they have this role, they can have access to this, or say that an employee was no longer with the company, then you could probably remove them from the access list. I mean, I don't know how you
where is the key stored then?
Where's the key stored?
Yeah. Private key.
Would you want to store the private key, or are you saying you want to store it?
I want to understand how you think about it. So I'm not suggesting anything. Just want to better understand how Phala is doing it. You know, what's the concept here?
Oh, within the secure enclave?
Yeah, maybe.
Yeah. You can store a private key within the secure enclave, but there's also a feature that we have. It's called the signing extension that we have with our Phat contract. So with there, you're able to deploy your contract, and then you can derive a key pair within the secure enclave. That could be temporary if you want it to be, but you can derive one for an AVM-based chain. You can derive one for any for substrate-based chains, and then that's how you're able to execute these cross-chain transactions. Because all you have to do is send your tokens to pay for the fees on that destination chain for the key pair that's derived. And then also, if say that you want to get creative, you derive a key pair and it's an employee, right? You derive them for all your different employees, and whenever they're done, you can just revoke it by cleaning it, so that there's no longer any access, and that key will be removed from the active set, I guess. This is how I could see it from the top of my head, at least.
Yeah. So you have this functionality implemented.
Well, that's the thing, is the Phat contracts allow you to customize it yourself. That's that programmable logic.
Yeah. Okay. But the base functionality is there. So for deriving keys on a by need basis, securely store it in an enclave. Yeah. Okay. Cool.
Right. Thank you. Yeah. Also, I'm gonna be here. Let's see. How much time do I have left? A lot. Oh, cool. Let's I don't know. Let's look at some stuff. Because I was talking about Swanky, so I wanted to kind of show some stuff. Because right now, tooling is kind of hard to have in the ecosystem currently. Let's see if I can. Trying to see what I did with it. So there it is. Yeah. So a really cool thing about Swanky is they're using OCLIF. I don't know if there's a cool proper name to pronounce it, but you can develop your own CLI for your developer environments, and then you can directly plug it into Swanky, which is pretty cool. And this is one of the things that I've been testing out, so that I can download all the binaries I need for deploying a local testnet for your Phala blockchain, to be able to just work on it locally, and you don't have to worry about posting it to our testnet. You can just kind of try it out. And I think the command that we do here is this, because it's the development version. I think it's Phala stack. And it this is one, if you don't have the binaries downloaded, it'll go out and download them for you. for like one of our recent releases, and you have to ensure that you're using like Ubuntu right now. And so like we don't support like Mac OS types of like development, but that's why I have like 2 computers, but mine in this case is Fedora. Let me check like on all this code. But there's also like a local like contributor or like an ecosystem contributor that built this thing called dev phase, and that is kind of like the first step so that we could actually like integrate with Swanky. So I can pull it up because like right here you'll see like I have my stack with I guess that this is like the latest nightly build that we have on here, and it's like downloading like the log server.contract, the log server side VM. So the side VM is like right now it's only on local testnet you can deploy it, but if you go through this step, you can start to see like we have the ability to run like a long living virtual machine with like synchronous programming and full SD library, but that's like high level. Like it's like way down the road for like implementation like in a secure way. But then you have like your system contracts so like say you want to deploy, you want to be provide your computation as like someone that's like is interested in Phala. You can deploy a cluster. You can have multiple computational nodes, and then you can have a runtime bridge to communicate between your cluster nodes and the Phala blockchain. And from there, you can write these system contracts. So the system contract allows you to configure like access control and certain access to different customizable functionality that you want to offer as a computation provider. So this gives like a lot of like cool, like interesting powers to like the computation workers, and I think and this is just kind of like to explain like these different binaries. And then we have the side VM deployer, which is what we have the log server. So whenever you look at our contracts UI, that's what this logs was using. It's like dead now, but yarn. Oh, I didn't. I'll figure that out later. But anyways, one thing is like, this is like kind of like some of the things that you may run into, like trying to develop locally. And if you do run into problems and you want to like figure out what is like the proper stack you need, what is the proper like steps to compile this like local testnet so that you can get up and running and developing, just like reach out to me or like reach out in our Discord, because I can step you through it. And if you have any like ideas you want to talk about, I can talk you through it. And also, like, I'm sure there's a lot of like very talented people with some very interesting ideas. And you know, I'm not like the most expertise, yeah, whatever the word is, like as like a developer. And I really like learning from people that are you know, more knowledgeable than me. And I look forward to like just talking to you all and just kind of like collaborating from there. So is there anything else here, or? Oh, it's because it's executing in our queries. It executes in the query, the HTTPS request. Yeah, it executes in the queries. So like it's not a transaction whenever you call to these like HTTP endpoints. So that's coming at no cost. And that's why it's kind of like interesting with like deriving that key pair and then having that roll up on the substrate, like having your other parachains integrate this like roll up palette so that you can just compose an extrinsic, sign it with that derived key pair, as long as you can send some funds to it, and then only fees you're paying is on that destination chain. So there's like the optimization of like not having to waste any block space on Phala and then just use the block space on another chain is like I think it's pretty powerful. And then it's also like kind of like an enabler other parts of your stack, or say like you don't really want, you see that some solutions like using these smart contracts to update like a price feed, and you want to use maybe like XCM with that chain. You have an open like HRMP channel or something, then you can just be enabled by that by just fetching that price data from there. Oh yeah, so that like it's going to be sent to some RPC node, yeah. It's just based on like which one are you connecting to. Like you can choose which RPC node you want. Rate, probably like a rate limiter. Like somebody like say like for instance like whenever we were like doing this with that CoinGecko API and we're interacting with it, we hit a rate limit. So like you have to like start thinking like what limitations are you gonna run into? Like if you're like you don't want to like DOS like all these different endpoints, but if, I mean that's kind of like up to I guess the developer, but huh? Like which, like the Phala node? Oh, I'm sure. I don't know. I don't think I can answer that like confidently, but I feel like you can send it out as many as you want, as long as I don't see like any. The only thing would be maybe like the cluster owner sets up their own rate limiter. Because okay, now I know what you're saying. Okay, we do have like a hard like rate limit on how many you can send out over a certain interval, because like you're saying, yeah, like okay, yeah, and then like say like you're a cluster owner, then maybe you can write a system contract to put your own custom limit on what your what developers can actually like send outside of your node. Good. Thanks for coming. I hope you have more questions like in the future. And then yeah, like we also have some beta phase coming. So like I think our applications are opening. I need to find the link from Zoe. She's here at Sub0 as well. She'll be one that you can say like you want to like try this out, and you want some support building out some application that you have. You can apply for this beta program, and we'll help you kind of build out your idea and like support whatever limitations you run into whenever you're developing. All right, thank you.